Using the latest technology, a seamless digital elevation model has been developed, which merges information from multiple sources to provide comprehensive information on ground elevation, both above and below water. Detailed above-water elevations were acquired using laser technology aboard a low-altitude airplane. During a field campaign in December 2011, an eco-sounder mounted on a boat measured elevations in the shallow and challenging nearshore regions. This information was used together with a high-resolution satellite image in order to extensively model elevation for the rest of the nearshore. Approximately 4 million elevation points spanning from 360 metres above to 40 metres below mean sea level were pulled together to create the seamless model. This information was ranked and mosaicked together based on accuracy, density and coverage characteristics. The finished seamless product can be used for both modelling and visualisation purposes. When the satellite image is draped over the model, a very realistic fly-through around Lizard Island is possible. Here we see the Lizard Island group, located in the northern Great Barrier Reef province and part of a unique set of granitic outcrops trending north-south. The fringing coral reef encloses a beautiful shallow lagoon named Blue Lagoon. On the least exposed northern side of the island, the coral reef rises steeply from approximately 30 metres deep, fringing the steep granitic cliffs. Here, the reef flats are narrower and less developed than those exposed to the prevailing southeast trade winds. Wave heights were modelled and calibrated using field data to explore the potential impacts of rising sea levels. The green mask shows the location of the fringing reef. Modelled scenarios are shown for winds of 26 knots blowing from the southeast, which are common during winter. As sea level rises following upper range forecasts, considerably larger wave heights can be expected inside the lagoon and the coastline. This will impact important ecosystems such as seagrass meadows.
The astonishing beauty of the world's largest coral reef, Australia's Great Barrier Reef, the pride of our nation. Extending 3,000 kilometres, up to 65 kilometres wide in parts, it abounds in the most extraordinary variety of marine life, including 400 different kinds of coral. But for how long? Lurking in the dark shadows of this pristine wonderland is a destructive and rampant predator, the dreaded crown-of-thorns starfish, known as Acanasta planki.
At the present time, crown-of-thorns and outbreaks of crown-of-thorns starfish are the single biggest cause of coral loss of the Great Barrier Reef. There's literally thousands and thousands of eggs in each one of these arms. So these are the gonads, and you can see that the eggs are quite large. So this animal is probably going to spawn within the next month or so.
Crown-of-thorns starfish have food in abundance on the Great Barrier Reef. They feast on our magnificent coral. They have up to 21 large arms covered in venomous spines. Spreading themselves over the coral surface, they suck the tissues of nutrients and colour, leaving a stark white skeleton, all within 1 to 3 hours.
We do know that it can really decimate coral reefs very, very rapidly. You can have a beautiful bay, high coral coverage, and if you have a big aggregation of crown-of-thorns move into it, within a matter of weeks to months, it can kill most of the living coral.
Dr. Lyle Vale is co-director of Lizard Island Research Station, operated by Sydney's Australian Museum and located in the Great Barrier Reef's northernmost island. Professor Morgan Pratchett is a research fellow at the ARC Centre of Excellence for Coral Reef Studies at James Cook University in Townsville. These marine science experts believe controlling crown-of-thorns starfish, most abundant in the northern part of the Great Barrier Reef from Cairns to Lizard Island, is potentially a losing battle.
Each starfish is capable of producing about 60 million eggs in a single season. So they really are just a bag of gonads. They have absolutely phenomenal reproductive potential.
Our underwater paradise is being bombarded by a growing epidemic of crown-of-thorns starfish, the fourth recorded since the 1960s. This latest plague is in some of the highest densities ever seen, and it's steadily gravitating south towards Townsville and the Whitsundays.
The accepted method is to go out and inject them with sodium bisulfate. The problem with this method is that it's extremely time consuming and you have to inject each starfish up to 20 times. So we've developed a new method, a single shot injection method where we inject them with ox bile, and the main saving is that each starfish only needs to be injected a single time.
But there are around 1.5 million crown-of-thorns starfish. Of the 2,200 reefs that comprise the Great Barrier Reef, 300 to 400 are infested with crown-of-thorns.
We've been protecting a couple of little reefs out here. You have to do a lot of dives to protect one reef. So when you swim over it the first time, you might get quite a few, but you're actually missing a lot of others. And they can walk in from nearby areas. So even though you're protecting one area, there might be a big population nearby, and they got tremendous sense of smell for coral.
Professor Morgan Pratchett's brilliant discovery of a single injection with ox bile is much faster, surer. But killing them is a band-aid solution, effective and sustainable only on relatively small areas of reef. We need solutions for widespread control and prevention of future outbreaks.
The two main hypotheses about the causes of outbreaks are firstly nutrient enrichment, where elevated levels of nutrients from land runoff are providing more food for the larvae and allowing greater recruitment rates, and the other relates to potential overfishing of key predators so that the starfish have fewer predators so more of them are surviving.
We really have to get at the root cause as to what's causing these outbreaks, and quite frankly, we don't know the full story yet.
We absolutely have to do something to reduce the devastating impacts, and this really requires a lot more research to understand their population dynamics, the causes of outbreaks, but also increased investment in finding new and improved methods to control outbreak populations.
The Lizard Island Research Station is the critical location for researching crown-of-thorns starfish. It was the site where field trials on the ox bile single injection method were conducted. This was a significant breakthrough, but we urgently need your support to find other additional methods for controlling crown-of-thorns starfish. The reefs are already in a very, very poor state, and this savage crown-of-thorns assault could decimate them. So please donate. Your contribution to the Lizard Island Research Station will help continue research to stamp out the problem and hopefully preserve the Great Barrier Reef for future generations.
Meet Hermie. Hermie is a little hermit crab with a big problem. Ocean acidification is threatening Hermie's home. 1/3 of the carbon dioxide pollution created by humans on the land is ending up in the ocean, making it more acidic and making shells and corals weak and brittle. Hermie is about to find out what a more acidic ocean will mean for him. Homeless Hermie needs our help. While his struggle to find a home had an unhappy end, the real future has yet to unfold. By cutting back our energy use, we can help protect Hermie's precious home. Our actions today will shape the oceans of tomorrow.
Overall, ocean acidification is bad news for coral reefs, as it is for a large number of species and organisms in the ocean. To survive and function as healthy ecosystems, coral reefs must be able to build and maintain their limestone structures. We now have good evidence that ocean acidification will slowly but surely deprive coral reefs of that ability. Ocean acidification is the chemical consequence of increasing carbon dioxide in the atmosphere. It's not climate change, but it has the same course, namely CO2. The more CO2 we pump into the atmosphere through emissions, the more CO2 is getting taken up by the ocean. Now, under ocean acidification, coral growth rate slows down, so construction also slows down. At the same time, corals become more fragile and brittle, so destruction speeds up. The balance between reef construction and destruction is now, under ocean acidification, a one step forward, two steps backwards process. Now, the consequences of this can be severe, as it means that reefs will be unable to repair themselves after storm damage. It also means that reefs will have less structure, and with less structure, they have less habitats for fish. Finally, reefs may not be able to keep up with sea level rise under ocean acidification. And just imagine what that means for island communities in the Pacific. Well, so far, ocean acidification has been regarded as a quite uniform threat, with risk to all coral reef areas globally being equal. What we have found in this study is that some coral reef areas in fact can modify their own pH, some in a positive way and some in a negative way. This really comes down to the biology of the reef organisms themselves. Now, as you know, coral reefs are made up of organisms that respire just like us, so they produce CO2 themselves, which locally can add to the problem of ocean acidification. But many reef organisms also photosynthesize like plants, so they take up CO2, which reduces the effects of ocean acidification. What we have found in this study is that areas with high rates of photosynthesis, such as seagrass beds and lagoon areas with sand and algae, can make coral reefs next door, so their neighbors, less vulnerable to ocean acidification. What this study can do is help us better understand what reef areas may be more or less vulnerable to ocean acidification. Now, this is a big step forward, as managers and policymakers have previously assumed that all reef areas have equal risk. This can help us better plan for the reef's future. It can help us understand how different natural reef habitats can help each other reduce the risk of acidification, and where we need to intensify our care and our management. For example, if we can promote healthy seagrass areas, we may be able to give critical or high priority coral reef areas a helping hand. In other words, we may be able to buy those reef areas some time until we can tackle the global threat of ocean acidification and climate change by lowering carbon emissions.
Researchers say they were horrified when they discovered that for the first time, mass bleaching had affected the Great Barrier Reef in consecutive years. When it bleaches, the coral isn't dead, but it begins to starve and can eventually die. The reefs, though, are resilient, but what concerns scientists is that more frequent bleaching, which is caused by rising water temperatures, makes it harder for the coral to recover.
Last year, the northern third of the reef bleached severely, and this year the central third of the reef has bleached severely. It's not irreparable, but it does depend whether we have more of these mass bleaching events occurring in the next few years, and looking at the global warming trajectories, we would expect that.
There's evidence the bleaching is moving south into areas that have previously been unaffected by the degradation. The Great Barrier Reef Marine Park is about the size of Italy or Japan and is so big it can be seen from outer space. The research team is warning that to save one of nature's true wonders, Australia must take decisive action on climate change. The government in Canberra has acknowledged that global warming was the biggest long-term threat facing the reef and has promised to protect it. The question is, can the future of this unique wonderland be guaranteed before it's too late? Phil Mercer, BBC News, Sydney.